Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge. The like button, the subscribe button, join me in Discord. Let me know what you think about this one. I have 1072 flip columns for maximum numbers of equal rows. You're given an R by C. I always read M by N as R by C because R by C is just way more clear binary matrix. You can choose any number of columns in the matrix and flip every cell in that column. Return the maximum number of rows that have or values equal after some numbers are flipped. So you can flip only columns, so there's no choice really. So every column you can either flip or you don't, right? Okay, what does that mean? Right. So it's a little bit confusing to read, and because they don't really provide you with any visualization, right? And just like looking at examples, I just want to make sure that I understand correctly, but it is a little bit tricky because they don't, they could have just drew this in an actual matrix, right? For example, you have something like this, 01, 10, and then ideally you flip 1 and 0, and then now you have all the rows the same, right? So okay, so what does this mean for us, right? The kind of things that what you would think about for problems like this is just try to think about what are the invariants of your moves, right? Well, first, like I said, is that it doesn't ever make sense to flip a column more than once, right? Because if you flip it twice, then you flipped it twice and it just went from 0 to 1 to 0, so everything is the same. So that's the first thing, right? The second is that yeah, what makes... Did I misunderstood this one? After flipping values, and if both rows have equal value. Did I miss? Okay, so this is the matrix. You flip 1, 0. Oh, wait, huh? Is when you say all values equal, I think that's the part that I'm just double checking. All values equals means that these are all zeros or all ones, or is it like equal to each other? I think that's the part that I think I'm a little confused about. I guess let's look at example 3. So you have this. So you flip the first two. You have 1, 1, 1, 1, and then 0, 0, and then there you go. Okay. Yeah, I mean, I think there are a number of ways you can think about it, right? The first way that I think about it is brute force, and as we said from the first thing, right, is that we only flip each column once. So what does brute force mean, right? Well, brute force maybe it's not that brute, but one idea would be that you flip for every row, make that all zeros or ones, right? And once we do that, then how many then you could do a check. Of course, if you do that naively, I mean, that's going to be R square. Yeah, and given that you have 300 by 300, so you can't even do like any bitwise smart trick. I mean, I guess you can still, but because 300 is just like what? Like 5 ints or something like that. But in any case, without that kind of thing aside, that's going to be something like, so we have R times C, and then every time you try one row, so every row we would look at the entire thing. So it's going to be R times C or something like this, which is probably going to be too slow, right? Given it's 300, that's like what, 27 million or something, yeah, right? Or maybe, I don't know. Either way, it feels high. Can we do a little bit better? Yeah, I mean, I think the way to think about it is that, okay, well, what does it mean to have each two rows the same? Well, I mean, the thing is that now we're trying to figure out how to denormalize or normalize, actually, I guess, the bucket so that two rows will match, right? So the first thing is obvious, right, is that if you have like two rows that are literally exactly the same, well, if they're the same, then you flip some columns, they'll be the same afterwards, right? No matter what. And then the opposite is also true, right? Is that if they're exactly the opposite, no matter how you flip, it is going to be exactly yeah, it is going to be exactly the opposite, right? So yeah, but the key part though is that because the exact opposite, if this is all 0, then the opposite is going to be all 1, and if this is all 1, then the opposite is going to be all 0, right? So that's really the idea behind, you know, bucketing. And once you do that, then we just have to normalize the number, and we should be good. Yeah. How do I want to write this? I don't even know. I mean, I guess we can use a number. I mean, you can also sort. Another way to do it is, yeah, I guess we can sort. Only because it's easier to implement. I think the way that I would actually consider doing it is, yeah, is the reason why sorting works is because, well, two things, right? One is that if they're equal, they'll be next to each other, and then you can also just check for the, like, you could do a sliding window thing, because as numbers get bigger, the inverse is going to get smaller. So you could do like a 2 pointers thing to kind of get to count all the values. So that's going to be actually, like, you know, with sorting, that'll be fine. Another way to think about it is just hashing, right? Yeah. And I think that there's actually even a trick that you can use, is that, well, if the invertness don't matter, then one thing that we can do is normalize a row, right? And what do I mean by normalizing a row? Well, if the row begins with the first number in the row is a 1, then we can just flip that row. And why that is that because it will always, like, there'll always be like an opposite, like, you could, what's it called? It's in the same equivalence class, right? Even though they don't have the same value, they're in the same equivalence class because they will, their answer will match with each other, right? So from that, you can maybe just flip that, and then you can do, you can either do a hash, or you can just do a sorting thing. Yeah, I think that's the way that I'm going to do it, is by using a hash, right? So okay, so for x in range of r, right? So then now we want to say if matrix of 0 of x of 0 is equal to 1, then we flip the entire row, right? Flip the row, right? Yeah, right. You can write this in a number of ways, but I flipped a bit. You can maybe do like it's equal to 1 minus this. Maybe that's fine too. Maybe that's like, I don't know. Is it cleaner for non-mathematical or non-bitwise thing? I don't know. It's definitely slower, but that's fine, right? Okay. So then now, like I said, you could do a sort and then find the streaks, or you could hash. So I'm going to hash, and actually, because we don't need, I mean, we could write out in another loop, but we can also just, you know, write as part of this, right? And we can just hash, right? So okay, so then now it is just, at least in this works in Python because there are big nums. You don't have to do it this way, but you know, I don't know. And technically speaking, the complex is a little bit iffy because of the shift and add. So depending on how you want to say it, maybe it is not, because shifting and then adding is kind of expensive. But oh well, whatever, right? So row hash is equal to 0. Yeah, I mean, you can actually limit the number of shifts, but whatever. I mean, I'm thinking of it in terms of bit mask, right? So that's going to be that. Yeah. And then now you have an R as a hash, and then we just put it in our favorite collection frequency table, and then f of r increment by 1. And then at the very end, it's just return what's it, max of f dot values, and we should be good as long as we have one value. Otherwise, the max would fail. But I expect that to be okay, right? So that looks good. Let's give it a quick submit. Yeah, looks pretty okay. A little bit okay, fine. What did I do last time? Oh yeah, the complement. Oh, I did basically the same thing, except oh. This is kind of sloppy actually, because this is a string hash, but I did plus minus or plus equal to for some reason. That made it worse. But yeah, you can also do it that way, I suppose, with a string hashing, so you don't have to do a big int hash that I did here in Python. It's just the idea of that. Okay, then now you have this, and then now you append right, and maybe convert it to a string so that we can just do f of right. Same thing, really. I do wonder if it's faster. That's why I'm trying it. So I guess roughly the same. Not really a big deal. But yeah, but technically the complexity of this one is faster. It's just that strings are kind of way more expensive than shifts. So, But yeah, this is gonna be all times C because everything is every element is just hit once here, maybe once here, and maybe once more here, so just 3 times at most. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you could I don't know what I'm saying anymore. Stay good, stay healthy, stay in school. I'll see y'all later and take care. Bye bye.